In this example, we're going to rationalize the denominator of two different types of fractions. In the first one, we've got a square root in the denominator. Now typically, when we have a square root in the denominator like this, 3 over the square root of 6, we would multiply both the numerator and the denominator by whatever radical is in the denominator. In this case, we're going to multiply by the square root of 6 over the square root of 6. Doing so is just like multiplying the entire fraction by 1. The result is that in the numerator we get 3 times the square root of 6, and under the denominator we get the square root of 6 times 6. But since that's a perfect square, we can reduce it to 6. However, we're not done, because we have a fraction that has a common factor in the numerator and denominator of 3. Canceling the common factor of 3 gives us square root of 6 divided by 2 when we reduce it. In the second case, we have a cube root in the denominator. When we have a cube root in the denominator, our goal is to find a perfect cube number that we can reduce out of the radical. So in this case, to get a perfect cube, 9, when it's multiplied by 3, gives us a perfect cube. We call that 9 times 3 equals 27, and the cube root of 27 is equal to 3. So bearing this in mind, we can rewrite our expression by multiplying the numerator and denominator here by the cube root of 3. So I take the numerator and denominator times the cube root of 3. My result is 6 times the cube root of 3 divided by the cube root of 27, which we know to be 3. So we've got 6 times the cube root of 3 divided by 3. 6 and 3 divide out, and we're left with the expression 2 times the cube root of 3. This, by the way, is a 3 up here, not a 6. And we're done.